with Chapter 5, kind of refine some of your queries. So basically, the reason we do a query is often to select information that's of interest. So if I have 10,000 burglaries somewhere, and I just want to analyze the burglaries that were of guns or bicycles, I could do a query if there's a field called type of burglary, and it lists, and that's what we did in the crime data. Students looked at data by burglary type. They looked at it by time of day. So you could query data by seasons. You could query it by time of day or by type, and then create a smaller set of data called a subset. And so with these subsets, you can kind of explore the patterns over time or over space and how they've changed. And you can also do a spatial query. So in this chapter, you're going to do both. You're going to do attribute queries and you're going to do spatial queries. So I might want to find all of the streets that cross a river and be able to identify them for bridge abutment. And I could do that. I could, instead of attribute, because there probably isn't an attribute in the street file that says crosses river, but I could do it by, does it physically overlay the river feature in my GIS? I could find all of the schools. That's what this student did. Find all the schools that are within 5 miles of the flood range, and be able to do that. So we're going to look at both attribute queries and spatial queries. So when we look at an attribute query, we're looking on some kind of value based on a field, right? So we might be looking in the income field. We might be looking in a categorical field. So in Chapter 4, you selected all of the Hispanics in the subregion, right? So you did a query by subregion and then by Hispanics, or Hispanics greater than a certain number. A spatial query is going to be based on location. So again, houses within a mile of a school, culverts that are not within 20 feet of a major river, those kinds of relationships. In an attribute query, there are logical operators, and these are just the kind of operators that you see in mathematical problems: greater than, less than, greater than or equal to. And there also are Boolean operators, and, or, not, and XOR. So when we do the queries, they introduce this in Chapter 4 using the SQL language. So the syntax, or the order that the language sentences are written, is there's always this select from layer where, and that's part of the query. You don't have to write that in. But then you have to pick a field, and then you have to pick an operator, and then you have to pick some condition. So if I want to select from cities where, population 210 is my field, greater than or equal to is my logical operator, and then my condition is 50,000. In the second example, I have two fields. I'm looking for population greater than or equal to 50,000 and males less than 50, right? So in this example, my selection has to meet both criteria. So I'm going to have a much smaller selection. If I had put or males less than 50, I would get a much larger selection. So when you select by attribute, again, you can do that from opening the attributes and doing that from the table. I think Price has you do it that way. Or you can go up to the main menu and select by attribute. You choose your layer, and this is where it automatically adds select from, and it states the layer, where, and then I get to choose my field. Here is population. I get to choose my logical operator, and then I can type in a number, or I can pick a number from the value list. And there is an error in this query right here on the left that you probably can't see because you're too far away. But there's is that a comma? Yeah, there's a comma there. And there are no commas in the attribute field itself, so this would blow up. This would not actually select because it's not going to find anything like that. Rarely do I type The logical operator, the Boolean operator myself, I almost always pick it from the list. Sometimes when you type it, it doesn't work, and I don't know why. But it's just safer to pick the operator from the list. And then I could click Get Unique Values if I wanted, and then click the value, and it would add it in here, or I can type it in. So you'll go through that. Well, this did not come across right. Name equals Alabama and name equals Arizona. So is that an accurate query, Travis? What do you think? What would I get if I type that in? Select from states where name equals Alabama and name equals Arizona. Anybody got an idea?
You get nothing.
Why would I get nothing?
Because you're trying to find a state that's named Alabama, Arizona.
Right. It's saying it has to meet both conditions, and there is no state that is named Alabama and Arizona. This one would work. And when I do this one, I'm going to get how many selections will be returned? Yeah, I'm going to get the state of Alabama and the state of Arizona, because I said it could be either one. I don't care. I want Alabama or Arizona. If it's either of those, pick it. If I say not name equals Alabama, I'm going to get 49 other states except Alabama, right? Not name equals Alabama and not name equals Arizona. I'm going to get every other state except these two. And
Are you sure about that?
no, I'm not. We could try it later.
Wouldn't that have to be a
Not
or?
name.
Not name?
I think for the not, the and actually works, which is really weird. But we'll try it. We'll try it. There's something funny about that one that I'll give it a try and let you know. Male under 5 is less than female under 5. Would that one work? So I have a field called male under 5, and I have a field called female under 5.
Yeah, I think it would work.
Yeah, that's fine. I'm looking in 2 columns. It's comparing in Oregon. If the males are under 5 or less than the number of females under 5, that's going to be selected, right? And it's going to go through each state and compare those 2 fields. And then there is the ability to choose, if I want to pick all of the cities that start with the letter C, I can say name like and then put in a wild card. And it depends on what you're searching from. If I'm searching from a shapefile, I have to use name like %, and it'll find everything California, Colorado, Connecticut. Go ahead.
You always have to use the %?
Ah, yes or no. Okay, so if my data is a shapefile, I have to use the % sign. If my data is a personal geodatabase, you might want to write this down. I have to use the % sign. And Mary Beth Price uses personal geodatabases, and this is an error in her textbook. She doesn't tell you that. She says if you use a geodatabase, use the asterisk, but that's only for file geodatabases. I believe we figured that out last term. If it's a personal geodatabase, it acts like a shapefile, and you have to use a % sign. So, I mean, the long and the short of it is, if you try the % sign and it doesn't work, try the asterisk, right? I mean, you should be able to try one of the 2 to get it to work. So that's that's kind of the section on queries. They'll take you through that. Spatial queries are looking at location, right? So it's going to use spatial operators like proximity, intersected, contained, those kinds of words. And there's a long list of containment operators. The really fun thing is that when you select the record, so I do a spatial query and I find all the schools that are within a half mile of a river. Maybe I want to look at those for flood mitigation. So I can take those selected files and save them as a new feature class. And Mary Beth Price has people save things as a layer file. And the problem with a layer file is that data is still connected to the original data set. So if I have 5,000 schools in Oregon and I select those that are next to a river, I might get 100. If I save those as a layer file, I'm only going to be able to see those 100 in my table of contents, but I have not created a new feature class. I'm still connected to the original 5,000 school feature class. And this is nice because I haven't duplicated feature classes. I don't have a lot of extra data. But it's really not nice when I want to do some analysis, because it actually does the analysis on the entire data set instead of just the selection. And then, because it doesn't look any different in the table of contents, you often forget that you didn't save it as a separate feature class. So whenever she says save things as a new layer, I always export them as a feature class and name them so that I know that I have a separate contained feature class that I can work with, and it's not involved in the other data. The other thing that you can do is you can select by attributes and then select by location. So let's say I select all of the schools that are elementary schools. So I would do an attribute query, find all the elementary schools, and those 1,000 elementary schools get selected. Then I can say, from the selection, select all of these that are within 1 mile of a river. So out of the 1,000 that are already selected, it will select 200. And then I can say, out of these 200, select from the attributes the ones that have the highest population. So you're not limited to only one selection. So I can select and then select from that selection and then select from that selection and then select from that selection. And so in the exercises, Price will have you do that. She'll have you select all of the cities within a 1 mile buffer of Oklahoma, and then from that select only those that are in a certain region. So she has you kind of using all of the tools of the selection process. In chapter 3, one of the things that Price had set up was a definition query. And she had the entire United States in the database, but she had the layer set so it only showed you Oregon and Washington, which is another way to kind of create a visual subset. She did that by specifying the shape. She said, go in and just only show Oregon and Washington, and then clip everything to just those states so that you couldn't see the roads and you couldn't see the rivers that were beyond Oregon and Washington. All the data was still there, but it was just a really fancy little way for her to set up her map. Okay, so let's look at a couple things.